Hello, everyone. I'm Priya Shanmugavadivelu, Senior Program Manager in Azure Compute at Microsoft. I'm so delighted to meet you all today in the Azure IaaS Day in partnership with Intel. And today, we have two other co-presenters joining us, Shiny Sebastian from Intel and Joe Pelly from Microsoft. Hello, Shiny and Joel. How are you both doing?
Thanks, Priya. I'm really excited to be here. Hello, everyone. I'm Shiny Sebastian. I am an engineering manager at Intel and part of the Microsoft Technology Center division.
Glad to be here, Priya. Hi, everyone. My name is Joel Pelly. I'm a principal group program manager in Azure Compute at Microsoft.
Thanks, Shiny and Joel. Once again, a huge warm welcome from all of us, and we are excited to share about the latest innovations in Azure infrastructure with all of you and how you can improve the price and performance for your applications. So let's take a look at what we're going to cover today. Shiny will kick us off with some key updates and features in the Intel Ice Lake processor. Joel will further expand on the new Ice Lake processor VMs and do a deep dive on the LAMP workloads with these new VMs. We'll then cover the ephemeral OS disk features and the supported VM types. And finally, we'll wrap up with a demo of the Azure Virtual Machine Selector, which will help you to quickly and easily find the VMs best suited for your workloads. With that, I'm going to hand over to Shiny now, and over to you, Shiny.
Thanks, Priya. Today, I'd like to give you a very quick overview of the latest and greatest Intel CPU, the third generation Intel Xeon Scalable processor codenamed Ice Lake, now available in Azure General Purpose and Azure Confidential Compute Infrastructure as a Service VMs. Today, we'll talk about two important points, performance and security. Compared to its previous generation Cascade Lake, Intel Ice Lake with the new Sunny Cove architecture has up to 40 cores per socket, has higher data instruction caches, has higher memory bandwidth, and several other architectural and microarchitectural enhancements. In addition, Ice Lake comes with new enhanced CPU instructions like AVX-based Vector ES, BPM add 52, SHA extensions, etc. And to top it all off, we have new security features like software guard extensions, SGX, total memory encryption, TME, and TME-MK, total memory encryption, multi-key, which I'll be talking to in the coming slides. Speaking of performance improvement, Intel partnered with Principal Technologies to publish Gen/Gen performance numbers on some of the most popular Linux database servers like MySQL, MariaDB, Microsoft SQL, on DV5 Ice Lake VMs versus DV4 Cascade Lake VMs. And we are able to demonstrate up to 40% performance gain with Ice Lake, with the popular benchmark HammerDB with popular workloads like TP-ROC-C and TP-ROC-H, which means customers can run their enterprise workloads on Ice Lake DV5, EV5 VMs and experience higher throughput. As more and more customers move to the cloud, we know that security is becoming a growing concern, which is why it's a priority both for Intel and Azure. When we talk about security, there are roughly two ways to look at it: data at rest and motion, and data in use and memory. First, let's talk about data at rest or motion. As you know, encryption is a computationally intensive operation, and the more complex the algorithms, the more the computational intensity, which is why with Intel Ice Lake, we now have CPU instructions to speed up these cryptographic operations, like asymmetric operations like RSA, ECDHE, symmetric operations like AES, and SHA enhancements, by parallelizing these crypto operations using AVX 512 instructions. The graph on the left that you see shows that we observe up to 54% performance improvement with Ice Lake, with the LAMP stack-based workload WordPress with different cipher suites and different VM sizes. Now, to make the adoption of these crypto-NI instructions easier, Intel has partnered with Bitnami to publish two VM images in the Azure Marketplace, one for Nginx and one for WordPress, for your deployment and benchmarking purposes. There are links given below. Please do check them out and speed up your crypto operations in your data center server applications and workloads in the new Ice Lake-based Azure DB5 VMs. And now comes the second part I was talking about earlier, data in use or in memory. Intel SGX, Software Guard Extension, is one of the most researched, updated, and battle-tested, trusted execution environment available for the data center. It's constructed to have the smallest potential attack surface within the system, enabling applications to communicate directly with the CPU and the encrypted memory, bypassing the OS and the hypervisor layers, which means It is designed to not expose SGX protected code or data, even in the breach of these privileged layers. This is why I'm pleased to say that Intel is bringing SGX to a full line of upcoming third-generation Xeon Scalable processors, Ice Lake, and even better, with the DCV3 VMs with Intel SGX, there's an increase of enclave memory size to up to 256 GB when compared to its previous generation DCV2 VM. Not only can you run larger data sets and workloads as part of your server applications now, these trusted execution environments make it easier for customers to run enterprise workloads and ensure their sensitive workloads are confidential. Continuing the topic of security for data in use or data in memory, let's talk about TME, where the entire platform memory is encrypted with AES-XTS 128-bit protocol. There are two benefits to TME. One, the encryption is transparent to the software, and data is encrypted when it's written into the memory and decrypted when it's read from the memory. No OS or application enabling is required. And as for the performance, it has been tested extensively both by Intel and Azure, and we see up to 2 to 3% very low performance impact for most of the use cases. Now let's talk about TME-MK. TME-MK stands for Total Memory Encryption Multi-Key, and it's a technology built on top of TME. In the case of TME, where the entire platform memory was encrypted with one key, now with TME-MK, we have up to 64 keys available on the platform, implying that every VM has its own key. Now, what are the benefits of TME-MK? It's similar to TME. No application refactoring is required. All the required support is already available in the Azure HostOS and Hyper-V today. As for the performance impact, it's similar to TME, where we are seeing as low as 2 to 3% performance impact on most of the use cases. Having said all that, we welcome you to bring your server applications to the Azure General Purpose and Azure Confidential Compute Ice Lake VMs and enjoy all the great performance and security benefits. I'm excited to have Joel join us to talk about the new virtual machines in Azure based on our Ice Lake processors.
Thank you, Shiny. Great info. Welcome again, everyone. Azure offers a wide variety of virtual machine families, each suited to the different needs of your workloads. Today, we're going to share some exciting new offerings across several of these VM families. Let's begin with confidential computing and the all-new Intel-based DCV3 series. Azure's DC series leverage Intel's Software Guard Extensions, or SGX technology, to protect your code while it's processed in the public cloud. Customers can use SGX to create secure enclaves that protect the data from the operating system, the hypervisor, and even Azure operators. From our DCV2 series, one of the most requested customer features was to increase the overall EPC size, so customers can load more code and data inside that trusted enclave. With the Intel Ice Lake processor and the new DCV3 series, the EPC size is increased from 168 megabytes to 256 gigabytes on the largest VM size. The larger EPC enables new scenarios like privacy-preserving AI/ML and bigger confidential databases. In addition, Shiny told you about a new capability on Ice Lake called Total Memory Encryption Multi-Key. With Total Memory Encryption Multi-Key, data in regular memory is automatically encrypted with unique keys without any required code modifications. The benefit to the customer is increased protection against other tenants on the same server. And this adds protection against a range of physical attacks as well, including cold boots and removing RAM. DCV3 remains non-hyper-threaded, with sizes now up to 48 physical cores, SGX EPC at 256 gigabytes, and memory up to 384 gigabytes. Encryption is on by default with Total Memory Encryption Multi-Key, and now you have options for sizes with and without local disks and accelerated networking. You can try out the new DCV3 series in public preview on the portal today in East US 2, Central US, North Europe, and West Europe. Availability will expand soon to additional regions. Now let's shift gears and talk about the D&E series virtual machines that are at the heart of Azure's VM offerings. Earlier this year, we told you about the DV5 and EV5 series virtual machines built on top of the Ice Lake processor and opened a public preview for customers to come and test these new offerings. Today, we are pleased to announce that the new DV5 and EV5 series virtual machines are now generally available. The DV5 and EV5 series are built on top of the new Intel Ice Lake processor, offering up to 3.5 gigahertz of a sustained all-core turbo, which enables an average 15% increase in performance as compared to their V4 counterparts. The new DV5 series offers a maximum size of 96 vCPU and 384 gigabytes of memory, while the new EV5 series offers a maximum non-isolated size of 96 vCPU with 672 gigabytes of memory. Both are an increase over the 64 vCPU size as compared to their V4 counterparts. Our team took in a lot of customer feedback to deliver a balanced solution of improvements in both storage and networking performance on the DV5 and EV5 series. These improvements allowed us to increase network bandwidth on the sizes up to 16 vCPU to burst up to 12,500 megabits per second, and the 96 vCPU sizes to reach up to 35,000 megabits per second. Remote storage uncached throughput and bursting is improved up to 45% over DV4 and EV4. In addition, the EV5 series now offers a 104 vCPU isolated size that reaches a maximum performance of up to 120,000 IOPS and 4,000 megabits per second of storage throughput. The DV5 EV5 series continue to offer support for sizes with or without local disk to optimize the cost and performance needs of your workloads, along with support for all remote storage offerings up to the latest high-performance UltraDisks. Now let's take a minute and talk about what this means when we apply it to your workloads. Web server applications are a really great fit for the Azure D-Series virtual machines. Leveraging open source software and WordPress on Azure, we utilize current deployment templates to build a highly scalable content management web serving system. This allowed us to demonstrate improvements in moving from our DDS v4 series on Cascade Lake to our new DDS v5 series on Ice Lake. WordPress on Azure is an EDE application deployment tool which includes many Azure components, such as virtual machine scale sets for dynamic workload scalability, file share for storage, and a synthetic load test to replicate traditional WordPress activity. We stress tested our WordPress website in a 30-minute long custom test that simulated up to 2 million users performing traditional activities on a blog post. Then we focused on monitoring the key metrics of total thread execution, or how many users were able to get their HTTPS request handled, and throughput, or the number of HTTPS transactions per second. The results were heavily in favor of the new Ice Lake-based DDS v5 VM series. The new v5 VM saw a 55% increase in throughput performance and a 58% increase in total thread execution. All up, this is a very positive indication that the new Azure DV5 EV5 series VMs will offer a strong performance improvement for your workloads. Now let me turn you over to my colleague Priya to tell you more about our exciting offerings in Azure.
Thanks, Joel. We have more exciting news to add to the Ice Lake VMs. Coming soon into preview is the new and improved memory optimized VM series, EBS v5 and EBDS v5, that offers up to a 3 times increase in VM to disk throughput performance and IOPS performance than the previous generations. So our customers who run data-intense workloads, such as the SQL Server, the Oracle DB workloads, or be it any type of relational or non-relational database applications, or even analytical applications, have let us know about their increasing demands for the remote storage performance. And Azure is committed to provide the best value to customers in both price and performance. And so here we are with this new and improved memory optimized VM series that comes with an increased I/O to core ratio and offering 120,000 in IOPS and 4,000 megabytes per second throughput. This new VM series comes in 2 flavors. The one with local disk is EBDS v5, and the one without local disk is EBS v5. And so now with the increased I/O to core ratio, you can consolidate your existing workloads into fewer and smaller VM sizes and get the desired cost savings. For instance, let's take the 64 vCPU VM size. The maximum throughput that's offered in the DV5 and EV5 series is 1,735 megabytes per second, which is a 45% increase from the previous generation. However, if your workload now needs much higher throughput for the same VM size, you can now try the EBS v5 or EBDS v5 that offers 4,000 megabytes per second throughput to get the desired cost savings. Also, if you're on one of the older generation constrained core VMs, try the new EBSV5 or EBDSV5 to get the benefit of cost savings. This new VM series comes in sizes from 2 to 64 vCPUs with a core-to-memory ratio of 1:8. The maximum memory that's offered is 512 gigabytes of RAM. And so do try out the new EBDSV5 and EBSV5 series by signing up for preview. So far, we saw all the new Intel Ice Lake processor virtual machine offerings in Azure. And now, we'd like to introduce you to the AMD's new EPYC Milan processor, general purpose and memory optimized virtual machine series. The AMD EPYC Milan processor runs at a base speed of 2.5 GHz. This new VM series also comes in two flavors. The one with local disk is DADSV5 and EADSV5. And the one without local disk is DASV5 and EASV5. The AMD series without local disk offers a lower price point of entry for customers. We continue to offer the support to attach standard HDDs, standard and premium SSDs, and UltraDisk as in the previous generations. Nested virtualization is another new feature that's available in the AMD V5 VMs. RI and spot instance pricing is also available. One of the key improvements in the new AMD V5 VMs is that they include faster and larger local storage drives than the previous generations. And for reference again, the AMD series that comes with the local disk is DADSV5 and EADSV5. So these new VM sizes offers a 50% larger local storage and about 2 times faster local disk IOPS than the previous generation DASV4 and EASV4 VMs. Now, these feature improvements are especially beneficial if your applications need a low latency and high-speed local storage, or if your application needs to read and write faster to the temporary storage, or in the case your application needs to use temporary storage for caching purposes. So if you're on one of the older generation AMD V4 VMs, switch to the new V5 VMs to get better performance for your applications. With that, we've covered all the latest VM releases on both Intel and AMD. We have 2 other product feature releases, Ephemeral OS Disk and VM Selector, that we'll discuss about. Ephemeral OS disks are ideal for stateless workloads where applications are tolerant of the individual VM failures, but are most impacted by VM deployment time or reimaging the individual VM instances. Some of the key benefits of the Ephemeral OS disk is that there is no storage cost for the OS disk itself. They support 50% faster reimaging of the VMs and the virtual machine scale set instances. They also offer 8 times higher write IOPS compared to the persistent disk. We have now enabled the Ephemeral OS disk feature on the temporary disk in addition to the VM cache. Ephemeral OS disk is also available on the new V5 VM sizes, including Intel and AMD, and a few other older generations. Azure is focused on providing the broadest and the deepest compute platform to enable choice for customers. And at the same time, we are also investing in making this platform easy to use for you. We have now launched the Virtual Machine Selector to help you to quickly and easily find the VMs that's best suiting your workloads. Joining us for the demo of the Virtual Machine Selector is Esther. Esther, please show us what's coming.
Hi, everyone. I'm Esther Indero, a program manager, part of the Azure core team. And I'm excited to demonstrate how you can use the Virtual Machine Selector. So let's get started. As you can see, you're provided with 3 options to begin using the tool. You can start by either selecting the workload type, or the OS and software, or the deployment region. For example, let's go ahead and choose the workload type. You can see the different workload categories that the Azure VM portfolio supports, and you can choose the category that best fits your workload profile. If you're not familiar with the workload categories, you can expand and read a brief description to better guide your choices. For the purpose of this demo, I'll be selecting the memory-intensive workload category. After that, you're presented with the option of specifying the basic attributes of your VMs. First on the list is the number of vCPUs, followed by the amount of RAM your application may need. Let's assume that I am interested in a VM that has at least 60 vCPUs, but not more than 80 vCPUs. You can enter the information in the tool and populate the corresponding fields. I will enter 500 as my minimum RAM requirement. After that, you can also enter additional advanced features that you may need, like the processor brand, GPU enablement, the size of your local temporary disk storage, the number of data disks you want to attach to the VM, and additional security and pricing options. We will be demonstrating how the tool issues recommendations that include both Intel and AMD-based Azure VMs. At first, let's start by choosing No Preference as the processor brand. Select Yes as the answer to the continuous performance of the CPU question. And select No as the answer to the GPU-enabled question. I do not need a temporary storage for this VM, therefore I will leave the field as 0. I would like to attach a minimum of 2 data disks to my VM, and will choose No as the answer to the security question. I would like to see all the pricing options that Azure can offer. That is why I'm choosing the No Preference option as my answer to the pricing question. Next, you can see how the tool is showcasing the various disk options that Azure can provide for you to store your operating systems. The page also shows the operating system disk size and specifications to best guide your choices. If you're not sure of the best option, you can leave the pre-selected options and click Next. On the next page, you can specify your data disk preferences and the number of disks you're interested in provisioning. Let's select, for example, premium SSDs and add 2 data disks to my configuration. After the data disk selection, you get to choose the operating system and software you want to run on your VM. I will choose Linux as my operating system and Ubuntu as the Linux distribution. Next is the selection of the Azure region to host your VM, and I'm selecting East US for this demo. As we go through the steps, you can see on the right side of my screen how the tool signals if we have any VMs that match the requirements you may have previously entered, in addition to a summary of the options you selected. Once you complete the region selection process, the tool shows the recommended VMs. Based on the information I have entered, I have the E64 ASV4 and E64 SV4 as the recommended VM, and there's also a list of similar and additional VM options that I can consider. I hope you enjoyed the demo. We're looking forward to having your feedback as we interface with the tool. An easy way to capture this is by using the Help Us to Make This Tool Better bar on the VM selector. Thank you.
Thanks, Esther, for the great demo. And I'm sure our customers will find great value in using the VM selector. And that also brings us to the end of the session today. Thank you for joining us today. We hope you liked the session and found it helpful too. We look forward to learning how you will innovate with these new capabilities to unlock your cost savings and maximize the value. Thank you once again.